In Steve Reinhardt's article, Never Say Anything a Kid Can Say, Reinhardt states that in 5 years he was able to almost completely change what and how he was teaching by making small, subtle changes. Steve Reinhardt's view of a teacher changed dramatically when he realized that a student learns best when they do the explaining and the teacher does the listening. He goes on to explain that implementing one suggestion may not result in major change, but when carefully put together, suggestions can change the complete dynamic of a classroom. He suggests to go slowly to avoid frustration and failure. Reinhardt's list of suggestions are as follows. 1. Never say what a kid can say. 2. Ask good questions. 3. Use more process questions than product questions. 4. Replace lectures with sets of questions. And 5. Be patient. When implemented at the right pace, Reinhardt claims that these steps will lead your classroom to success. Reinhardt reminds his students regularly that participation is not optional. This displays a sense of comfort and trust in his classroom. He finishes by saying, I am convinced that children learn in more ways than I know how to teach. In Glenn Gabbard's article, A Mathematical Cornucopia of Pumpkins, Gabbard makes a claim that a mathematics investigation has multidimensional content, is open-ended with several acceptable solutions, is an exploration requiring a full period or longer to complete, is centered on a theme or event, and is often embedded in a focus or driving questions. He clearly lays out his lessons separated by objectives and materials, including a results table. For each lesson, Gabbard lays out for us how he implemented his claim of a mathematical investigation as stated before. Gabbard clearly explains how each lesson plays out and what each student should take from each lesson. Gabbard finished his article by saying, for investigations in mathematics and science to engage students, they must be fun. This article is titled 10 Practical Tips for Making Fractions Come Alive and Make Sense. The authors of this article agree that many teachers find fractions difficult to understand and many students find them hard to understand. This article offers 10 tips that Clark, Roche, and Mitchell think will make fractions easier for students to understand. Number 1. Give a greater emphasis to the meaning of fractions than on procedures for manipulating them. Number 2. Develop a generalizable rule for explaining the numerator and denominator of a fraction. Number 3. Emphasize that fractions are numbers, making extensive use of number lines in representing fractions and decimals. Number 4. Take opportunities early to focus on improper fractions and equivalences. Number 5. Provide a variety of models to represent fractions. Number 6. Link fractions to key benchmarks and encourage estimation. Number 7. Give emphasis to fractions as division. Number 8. Link fractions, decimals, and percents wherever possible. Number 9. Interview students one-on-one on the kinds of tasks discussed in this article to gain awareness of their thinking. And number 10. Look for activities that can engage students in thinking about fractions. This article is titled Unpacking Word Problems for Diverse Learners. In this article, the authors indicate that research indicates students with disabilities perform lower in math than peers without disabilities. And in a given problem, students must be able to do the following. Number 1, read the problem. Number 2, identify important versus extraneous info. Number 3, identify the unknown information to be solved. Number 4, choose a strategy appropriate for the problem type. And number 5, solve the problem correctly. This article states that efficient problem solving requires a student to be analytical. This article states different kinds of schemas that work in a classroom. For instance, the combined schema refers to a combination or collection of things. It is important for students to understand that the quantity of objects discussed in a combined problem does not change. Another schema is the compare schema. This schema does not involve a change in quantity. The compare schema differs conceptually from a combined problem in that students are not considering a combined collection, but are comparing two different quantities. There's also the change schema. Change is a schema most students are familiar with and accustomed to solving in the classroom. These problems include a change, increase, or decrease in the quantity of a set. In this article titled 13 Rules That Expire by Karen Kark, Sarah Bush, and Barbara Daughtry, the authors point out a list of always rules that are not so always. These are rules that expire. For each of these rules, the following should be done. Number 1. State the rule that teachers share with students. Number 2. Explain the rule. Number 3. Discuss how students inappropriately overgeneralize it. Number 4. Provide counterexamples. And number 5. State the expiration date. The following are the 13 rules that these authors The following are a list of rules that these authors say expire. Number 1. When you multiply a number by 10, just add a 0 to the end. Number 2. Use keywords to solve word problems. Number 3. You cannot take a bigger number from a smaller number. Number 4. Addition and multiplication make numbers bigger. Number 5. Subtraction and division make a number smaller. Number 6. You always divide the larger number by the smaller number. Number 7. Two negatives make a positive. Number 8. Multiply everything inside the parentheses by the number outside of the parentheses. Number 9. Improper fractions should be written as a mixed number. Number 10. The number you say first in counting is always less than the number that comes next. Number 11. The longer the number, the larger the number. Number 12. The please excuse my dear Aunt Sally rule. And number 13. The equal sign means find the answer or write the answer.